Information retrieval is a part of computer science which studies the retrieval of information. Remember, information is not the same as data. And in fact, I think as used here, information might even be knowledge, because information is, the way I usually define it, just cleaned up data. It's not terribly different from data, whereas knowledge is information with some significant value added. Um, so you could use databases, but databases have too clumsy, not clumsy, too restrictive, structured interface. We need a wider variety, a wider choice of things we can do. And so here's some key things we have to worry about. And this points out that how you could do the data, information, knowledge, wisdom. So where you start off with raw web pages as data, the result of the query could be thought of as information. Um, knowledge could be the result of processing the query results by the user, and wisdom comes from synthesizing many such actions by one or more users. I would say normally data is nearer information, so I would tend to say this is not the only way of doing this classification. When I introduced DIKW, maybe data is reasonably clear and wisdom is reasonably clear, but I and K, information and knowledge, are not so clear. And I say you can even do a slightly richer classification, raw data, information, knowledge, wisdom. So here this points out the difference in information retrieval, which focuses on relevance, slightly fuzzy, and databases where you have very clear SQL commands. And if you search for semantic web, it will demand that you see the phrase semantic web in any document that's returned. Whereas the goal of information retrieval is to find all documents about the topic semantic web. And in principle, you do not even have to have the term semantic web in the result of what you get. So here it points out if you type semantic web at Google, it gives you back Wikipedia as the top link, and then the W3C activities. And so these two are possibly two of the most significant semantic web links if you're actually interested in the topic. Here's a comment on the difference, which is sort of a related comment, as well as difference between information retrieval and databases. We can study the difference in keywords, which we'll discuss a little more later on, and full text. Keywords are nearer what databases focus on, and full text is more nearer what modern search engines focus on. Keywords are clearly more precise. The trouble about keywords is it's very hard to get accurate keywords for general documents because that has to be done by people, and also to do keywords you need a so-called ontology, which is a list of possible keywords, and it's difficult to get agreement on ontologies. To show you what an ontology could look like, here is the ACM computing classification scheme from 1998, and it divides up programming into all sorts of different ways. Here's software engineering, here's hardware. I must admit, I think this is not very successful because over the last 15 years, the important areas of programming have changed. MapReduce is important in clouds, or the language of Python, which we're using in this class, is important, which did not exist. And so actually this tends to be above the particular languages, but it's still true. that the divisions that ACM has, which are maybe the best you can do, are not so obviously, they don't obviously keep up with rapidly varying fields and diverse needs of users querying what's going on. So I personally find full text search often much more useful. There are some good ontologies. The Dublin core is one that, say, specifies core document information like author and title. Another approach you'll see, say, a well-known social networking sites, they all use tags. Tags have an interesting feature. They tend not to enforce ontologies. They're just whatever the user wants to tag. And I think that is better than keywords. I actually wish current system that use keywords switch to using tags. And then when you query the system, it does not insist that you spell the tag correctly, because in many cases keywords are added by users and they actually add them inconsistently. So full text is more challenging, but this is a richer area, and in general I think full text has been shown to give better information than keywords. So I think when people first looked at the web around mid-90s, they thought that keywords and things like that would be very important and key to indexing the web, but I don't think that's true. I don't think that turned out to be true, because full text was much more powerful and reliable than people expected. So if we look at the special case of information retrieval called web search, you need to note that the web has some special features, namely web pages are linked together with in a rather clear fashion through the hyperlinks. Books are sort of linked by citation, but that link is less strong and less valuable. Although even that's pretty useful if you want to find out some information. Going to the citations in a document is a good way of finding out other documents on the same field. And of course, so compared to other types of information retrieval, the number of documents and diversity of documents and the rate of change of the documents is very high. And there's also a lot of spam. And there are a lot of users trying to find out what's going on.